Yeah, I guess it's nice to meet y'all. My name is David, as Chris said, and just to give a little bit more background about me, I have been in the software industry for about 7 years or so now. I was originally not in tech or anything like that. I was a piano teacher for a few years. I went back to school. I studied physics. I worked in a computational physics lab for a few years. And then I ended up working as a software engineer for VMware, actually like a smaller division of VMware, which was working on a essentially like an application deployment platform for the cloud, similar to like I guess Heroku, if anyone's ever heard of that. And after working there for a few years, I joined Meta, at the time Facebook, about 2 years ago. And the division I ended up in at Meta is actually their part of what they call the observability platform at Meta, which I'm going to basically try and talk about this space today for y'all. So logging and observability in distributed systems. So I guess just to, oh yeah, and by the way, feel free, anyone, if you want to chime in or ask any questions during the talk or after the talk, if something's not clear or you want to kind of dive into something, that's totally fine. So yeah, I guess since I came earlier from a slightly physics-oriented background, I just wanted to talk about, in a general sense, how do we know about the state of systems in general. So a system can be any size, right? It's just kind of a thing that we care about, like maybe an atom, which is actually kind of complicated, even though it's just one atom, like a car, or maybe the weather pattern in North America. So these are all systems that you might care about, knowing something about them. So typically, and this is kind of almost silly, but you would take a measurement, right? If you want to know something about a system, this is kind of a common sense. So like if you want to know about the weather, you might, take a thermometer, take a measurement, say, oh yeah, it's 78 degrees outside. Usually there's a time and a place that you're taking that measurement. So these things are usually a function of time and space. So like, for example, here's a chart of the weather, of the temperature monthly in Canada. And obviously there's things you can measure that are not numbers as well. Like if you're looking at a car, you could say like, so hey, this part looks broken to me, or more in the domain of software, you could say, hey, like the web server is, throwing some exception, or I'm seeing some error log in the whatever log file you're looking at. And yeah, so in physics, these are called observables, which has like a very careful definition, which we don't really care about for most practical purposes. So for most practical purposes, right, you can take a measurement, you can graph it, you can say things about it. And so this is just kind of a cool picture that I saw while I was researching for this talk. This is an object called a dropsonde, which I'd never heard that word before, but apparently it's this small cylinder, completely disposable, which weather researchers for the government or universities will basically drop these things with a parachute into usually hurricanes in the Atlantic Ocean. And basically it kind of descends, and there's a small computer with a few sensors and a radio attached. And so as this thing drops through the hurricane, it will transmit, location, pressure, temperature, humidity, right? A series of numbers. at different altitudes, and it'll, radio that information back to the, I don't know, airplane, boat, island, wherever they're receiving the information to process. And so, yeah, this basic idea is kind of universal to engineering, not just software. But so this idea or this field is called telemetry, which is pretty simple. It just refers to the fact that you're recording like a piece of useful information somewhere. Typically, you will transmit it, right? In that case, it was transmitted over radio, and then you have kind of a receiving end where you can, store the information, analyze it, do something useful with it. So yeah, this is very, very prolific and universal. Like almost every engineering field or industrial field uses telemetry, like airplanes, weather research, like if you're mining or drilling, cars have sensors that are constantly transmitting information about the state of, the whatever system you're caring about. So yeah, this is just kind of what telemetry talks about, like in the very high level. But since most people here are interested in software, and that's where I've worked in also recently, we can talk about more specifically telemetry in software. So this is also called observability for obvious reasons. There's also a common buzzword in the industry called APM, which is short for application performance management, metrics, monitoring. We'll just call it different things. But basically, there's like 3 big domains of measurements that people are taking in software. Like one is just unstructured logs from a program. Like, you have lines of logs from your web server that's being recorded, usually by default, just like on a local file on the web server. But more sophisticated systems, right, will be streaming these logs to some collection point for storage and analysis. And so the other type of information is, like we were saying, just numbers, metrics. So these might be like, the successful requests per second, like the bandwidth per second, errors per second, things like this. And these are just straight, number graphs to represent the system. And usually they're represented actually as percentiles in production cases. So you might say like, the 99th percentile, like the slowest 1% of requests took this many seconds on average, or you might say like the 90th percentile took this much. And usually in production systems, people will kind of define if their system is broken or not based on some kind of a graph of numbers to say like, oh, if your 99th percentile request is faster than 2 seconds, you say the system is up, otherwise you say it's down, and usually someone gets paged and like needs to go fix it. And so a third type of logging, which is becoming quite prolific in the industry and is actually kind of what I wanted to focus on a little more further in the talk, is this thing called distributed tracing, which is basically if you have a bunch of different services talking to each other for the duration of a single request, you can, I guess, like record that graph or like that structure of, service A is talking to service B, is talking to service C, and you can kind of do useful things with that information. So typically, so there's a lot of different models for how telemetry is collected in software, but I would say like the majority of use cases that I've seen and that are kind of out there in production are something like you import a library, right, into your server code or your whatever. So I just kind of looked up this APM software called Elastic and looked at their instructions on how to like inject it into a Rails server. So usually you just kind of import some package, you set up some configuration for it, and then in most cases, right, you're going to want to transmit that information somewhere. Once you instrument your web server, you want some place to store it, and you want kind of like a UI system, right, to make graphs or like to do querying on the logs. And usually you also kind of want some alerting or paging system to, you know, I don't know, have some actionability from the logs that you're recording. So yeah, this is kind of like a non-trivial problem to solve, right? So both the, you know, creating a library to structure logs, you know, creating a system to transmit them, creating the processing, the storage, the UI for analyzing logs. And there's a lot of value in this, right? So just at the high level, from an operational point of view, observability into a system is going to let you fix things faster, ideally fix things before they even break, right? For a very large system, maybe you can see that something is starting to get funny with it and you can not avoid even having any downtime. This is, you know, obviously very valuable to big sites, which generate a lot of revenue for, you know, every second or minute or hour they're down, they might be losing a lot of revenue. So that's just on the operational side. And on the other side, on the performance side, you can kind of use this information to improve systems. So this usually takes like two forms. You can maybe make it faster, like improve latency of your system, or you can maybe just make it more efficient, period, and reduce your infrastructure expenses. And so sites that are large, right, and generate lots of revenue, like Amazon or even smaller sites, will typically have really, really high infrastructure costs running into, right, millions, even billions of dollars, depending on how big is the site. So that's kind of another big use of observability, performance logging. And so a third, which I'm less familiar with because I've never actually worked in the security space, but a lot of logging is also used for security, right? For trying to detect attacks and ideally prevent certain types of security threats. So yeah, so this is kind of this data is often super valuable to companies, and it's also a hard problem to solve. So like anything, it's like a hard problem to solve that's super valuable. There's been a lot of investment in this industry. So I just kind of browsed through and took a look at the largest logging and metrics companies that have emerged in the last 10 or 20 years. And there's a lot of them, right? And there's hundreds more. And there's whatever billions of dollars have been invested in this industry, and there's like lots of very large companies that these companies on this list almost entirely their only focus is logging and metrics. So yeah, it's kind of an interesting space. It's a large space. It's kind of been evolving a lot over the past 10 or 20 years, right? As different trends happen, and you know different ways of deploying software happen, then you know changes need to happen in how logging works and metrics works. So I was actually gonna start to do like a slightly deeper dive into what distributed tracing is, because I think it's one of the newer, well, in the last 10 years or so, newer types of logging that started to get popular. But yeah, I guess if anyone has any questions or anything, happy to chat, or we can continue.
I think we're going good. We don't have any questions in the text chat yet. And I think there are a few people I muted myself, but typically, if I haven't muted you, then you can unmute and ask questions as we're going through here. But I'd say we're good for time. You're free and clear.
Cool. So yeah, so the reason also partially, so yeah, I want to talk about distributed tracing. So we've basically talked about stuff that's not really actually particular to a distributed system, right? Like even if you have just a single node, a single web server, you can kind of record logs locally. Maybe you can hook up some UI to read the logs or search the logs. You can have, health metrics, stuff like that to monitor like a single web server or like a small cluster. So yeah, none of that is actually specific to like large distributed systems. But there's a concept of logging called distributed tracing, which is actually specific to distributed systems and is kind of meant in particular to debug them and improve their performance. So yeah, and actually when I joined Meta, I ended up in the observability group at Meta that deals with distributed tracing. So I was working on their tracing platform, and my particular team was trying to basically get value from these traces and try and do useful things with them. So the basic idea, right, is that in modern software systems, usually there's more than just a single web server. Usually there's multiple services, right? So in the simple case, maybe it's a web server, which is talking to a database, which is a different machine. Or maybe it's a web server that talks to a different server, which is supposed to be like your shopping cart service. And then that server talks to another database. And so you have this whole like network, right? Or this tree basically of you're going to have an entry call, right? Usually you have just a single API call or whatever. Somebody loads an endpoint on a browser, and that's your entry point, but then that's going to branch out, right? It might call a lot of services under the hood. And mathematically, this is called a graph. Like this particular type of tree is like the formal terminology is a directed acyclic graph. It just doesn't really mean anything. It just means that you have like a single entry point and it kind of branches out and there's going to be no loops in that graph. So yeah, so the basic idea of distributed tracing is every single server that it's receiving that request through the lifetime of a single request, you kind of log a little bit of information from that server during that request. You just log enough information that you can recreate the tree of calls, and you can record interesting information about that, right? The most prominent is usually like latency, right? So you might say that, oh, hey, this web server A got a request. The whole request took 300 milliseconds, but within that, it called all of these individual services as a part of a request, and each of them had, this latency inside of that. And so you can kind of understand, where are the bottlenecks, what might be broken, what might be able to be improved. And yeah, there's kind of a lot of use cases you can think of with this kind of information. And so this is kind of just an example UI from a popular open source tracing system called Jaeger, which was originally made by, I think, Uber, the company, because Uber prolifically uses microservice architecture, right, where they have hundreds or thousands of different services that are calling each other for even a single request. And so this is usually what the UI looks like kind of for visualizing a trace. Like, so you'll see some kind of entry, right, into the front end web server or whatever front end API server, and then that will call a whole bunch of other stuff, and you can kind of visualize what stuff was called, how long it took during that call, if there were any errors during the call, and so forth. And yeah, so for a simple system, this maybe is kind of overkill, but for very large systems that are, or for companies where distributed architecture is very popular, you might have extremely complicated call trees. So this is just like a image from this talk given by Yuri Shkuro, who was I think the lead engineer who designed this open source tracing system at Uber. And I don't know if this is actually a visualization of a real call, but just like in my experience at Meta, there were many, many calls that were of similar complexity to this, meaning there might be hundreds or thousands, right, of dependent service calls happening. So yeah, it's kind of impossible to reason about unless you have a system which is connecting the dots for you and letting you visualize what's happening. So yeah, I guess I was talking a little bit earlier about the value of this data or what people like to do with it, but big values, right, are latency debugging, like a request is slow. There's hundreds of services being called. Which one is the bottleneck? You can talk about performance analysis, right? Like what does a request cost, right? Because if it's calling hundreds of dependent services, you have to add up the cost, right, of every single request in that tree. You can debug system failures, right? Like if a particular API is broken, like which dependent service has broken. And so yeah, this was from a talk given by some engineers at Meta who are actually I worked on a team with them. And so our team, right, one of the things we were trying to do with traces is this idea of like cost allocation, or we called it resource accounting, right? So if you say that like both Instagram and Marketplace are calling like this whole network of shared services, which are then in turn calling this whole network of shared data services or databases, like how can you tease out, right, like what's the real cost of like Instagram versus what's the real cost of Marketplace? So yeah, it's kind of interesting. And yeah, so that's basically kind of what I wanted to talk about today. I have this, this is just like a Google slide deck. I think Chris is gonna post a link to this. I just put a few kind of interesting links here at the end. They're white papers on like the internal tracing system that Google made, Meta made. I probably should have put one for Uber as well, but anyway, yeah, just a few more interesting things about the space. So yeah, that's about it.
Awesome. Thanks, David. So I'm going to pull up that link and share it in the Discord for the slides, if that's cool with you.
Yeah.
And then, and just in case anybody has follow-up questions on that stuff, I went ahead and put a link to that Jaeger tracing library as well, or framework, I guess. And it looks really interesting. I mean, some of those visualizations are just like so compelling. I think partly because there's the complexity, but they've also, I don't know, they've spruced up the illustrations so that they're very clean. The data visualization side of it's evolved a bit. I did data visualization probably about a decade ago, more formally for a while, and it's neat to see the tooling really evolve. So I suppose, the distributed tracing as such, it's looking at this library, it looks like that, it puts stuff into Postgres, or there's a way to anyway if you want to. But in terms of the overall architecture, the way of approaching distributed tracing, like as a goal, for a system, you know, are there specific implementation approaches that you think make sense if an organization's going sort of from zero to like, oh, we need to be doing this, that you've touched on? Because it sounds like mostly you've been working with, these big established systems that are already online in a way, right?
Yeah, so there's a difference. There's like, yeah, obviously a huge difference between like a mega corporation,
Mhm.
mega tech company, like
Right.
Google or Facebook or even Uber, right, would qualify probably as like a mega tech company. So these
Sure.
bigger companies, they have a tendency to essentially re-implement complex systems completely internally, right?
Right.
So Facebook created their whole distributed tracing system from scratch. Google created their whole tracing system from scratch, and Uber did. They just, I guess, Uber happened to open source it before anyone else, and so then this system became popular. But generally, like for like more mid-size or normal companies, right, that might just, whatever, they have a few hundred servers, they're talking to each other, they want to maybe implement tracing, the answer is almost always going to be, go to one of these APM companies, right?
Right.
Where they
Right.
usually, and some of them actually are just, they've just packaged, right, these open source products together in like an easy, way to use it. So it might be that, oh yeah, here, if you import the Jaeger library and just like point it, to forward its logs to, our whatever cloud log provider, then you can go log in and look at your traces, right?
Right.
So
Right.
that's like the practical answer, right, for most companies, which is part of why, these APM companies have become so large, because lots of them just kind of provide a tracing platform as a service, or even just like
Right.
even just regular logging, right, is a non-trivial problem to set up if you have a ton of servers and you want to easily search through your logs and see
Well,
what's
and
going on.
just given the shape of the problem, I mean, it sounds like the kind of thing where probably half of the companies that were raising money around this topic over the past couple of years were, filing it under blockchain, or at least using that word, right? And there's in some sense a good argument for that concept anyway, of like, just for the technical implementation of tracing along all of these different systems, right? And having timestamps and yada yada. So, but when you get into the actual accounting with a company, right? Like, what was the term of art y'all had there? The resource allocation, resource
Yeah,
accounting?
I don't know if that's like a broadly used term, but they
Sure.
called it resource accounting internally at Meta. Uh,
There, there's a similar concept at Amazon, I think, that's, generally speaking, right? It's like this accounting concept that, you want to know who's incurring the costs, like which departments, which lines of business, and then, but doing that sort of at this, by the second or millisecond, as it were, and across an entire system of software that's running, in different environments and all of that. So there's that idea of using the percentile threshold along with like the metric threshold, and you're defining that at some point of like a system being in good condition or bad condition. But I suppose it makes sense that there's this sort of shape to the market where there's, the big tech players who solve the problems for themselves in house, and then open source and the network effects from that. But then beyond that, it's sort of everybody's buying it as a service. And then they may or may not be the conversation about like how to use it, how to set it up, what to tie it into, sort of, there's the fitting work that has to happen, I suppose, at that point. Um, so there was another thing I was thinking about, which is with the big companies, I wonder how much they've been hit by like the tracking stuff that I know has hit e-com and the like ad space in general, with Apple tying down tracking, right? So I suppose like when that sort of systemic change happens, I imagine there can be like big effects for these systems, and then you have to sort of tag that in some way, right? Like, so like at Facebook, when they started dealing with the new iOS privacy limitations, right? did that get tagged in the system in some meaningful way, or is that sort of outside of your?
So there were like not specifically the iOS changes, but in
Sure.
general, a lot of kind of privacy concerns at companies
Right.
about like what kind of data are you logging, where are you storing that data, like do you
Right.
have good measures or like sufficient measures in place to prevent that data from, being leaked or
Right.
whatever, or used in a different way than you got permission from the users. Uh, Obviously, this wasn't on many of these companies' radars like 10 years ago, but obviously today this is like on the
I think.
radar,
Yeah.
large companies
Yeah.
to a big degree. Uh, and so actually, so interestingly, so about specifically about recording data for ads and for ads targeting. So because that's such a sensitive area,
Yeah.
and like because there's so many controls in place, especially right with the business environment and political and legal environment today, like there's like at least at Meta and I would think at most companies there's actually a division right between
Mhm.
operational logging and
Right.
ad logging in particular, to
Oh,
where it's
interesting.
completely different organizations, completely different databases, completely different like people working on it, right? Like the
Right.
team
Right.
that
Right.
does
The
ads
team
log.
separation. Yeah.
Yeah,
Yeah.
exactly. Because the operational logging, right, you might be able to, get away with logging more. You might say like, oh, this is purely for internal operational usage, right, for efficiency and keeping the lights on. So maybe you would just like segregate that data over to one side and let that team work on it. But then like if it's actually ads data or personal data or stuff that's used for ads targeting, there might be all of these like legal requirements, right, that you want to maintain, right?
Right.
So yeah, that's the model that was at Meta, and I would think that actually at most large companies that get their money from ads, there's probably something similar, right, where
Wh-
there's infrastructure
Which,
for operational logging and versus
right.
infrastructure specifically for ads logging.
Which is in a sense to say, like the the measurements and the reporting and the tracing, right, is sort of, you know, implementing separately of what, the ads team is needing or delegating or what their goals are, but there's a conversation back and forth there, to like help the teams know what they need to know to do their jobs, right? And the way that, basically the observability system evolves to like conform to the system, the overall system, right? Um, and that's evolving at its own speed as well. So the and like security sort of runs along with that in an interesting way. So it's the idea that there's sort of this separation between all of these sort of related, initiatives, right? Because it's like security does sort of run hand in hand with it, and then accounting does sort of run hand in hand with it. Um, that idea of just observing the overall system is something that a lot of teams share and then have different degrees of agency within it. So I suppose part of it is like, you know, validation of the data that you have to ensure the information that you're providing. Um, that that seems to need some sort of recurring like reconciliation or like I forget what you call it in finance, but it's like the clearing, a few days later to make sure everything is good, that everything was running according to sort of the spec, right? Um, and that things haven't drifted underneath that. I suppose, I'm thinking about it in part because I know that for like SOC compliance, right, which is sort of like the one of the standards at this point. I forget if it's two or three. SOC 3 compliance. Uh, they document that through screenshots of like settings, and it feels as though the size, the sheer scale of these data concerns, right, and knowing what's happening in the system suggests that there needs to be like, a bit more of a an assist in helping us ensure, some of these systems are operating the way that we want them to be operating, right?
So yeah, no, actually interesting you say that because I didn't mention privacy or compliance as a use case, but that is actually one of the major use cases
Right,
for data
right.
at both Meta and other companies, usually again mega companies that have such large infrastructure that it's kind of hard to wrap your head around it, or just
I mean,
list on a
even
spreadsheet what.
small companies, even
Right, which
have
in some
trouble with
way
things
is
like,
that might be a sort of a good way to segue out because it looks like we don't have any questions,
I've got a question.
but we do have a few people who are still holding on in the chat. So I'll say, in my mind, the point you made about the how we need a system of some complexity to help us navigate the complexity of the system that we're observing, right? That idea is that it's impossible to debug without a system to assist you, right? It takes a bit of the anxiety out of the past couple of weeks for me with all the chat GPT and um it's like, is the AI going to render all development efforts sort of obsolete or expendable? And I think the reality is that, well, I mean, I'll leave that there, and then I have my follow up on it. But like, do you feel like a lot of this job is going to be like having some AI suggest the system and then implementing it and tuning it up from there, or does that not even enter into the picture for you
I
right now with
mean,
this stuff?
I can't really predict the future, but uh, it's hard to see how that would happen sooner than 5 or 10 years or even 20 years from now. Because it's true, like AI systems have been kind of progressing in an exponential fashion, but at the same time, like yeah, like there's systems are difficult to manage, right? For a lot
Right.
of reasons, uh, and yeah, that's kind of my.
That's probably the simplest way to put it, which is not not a dig at all. I mean, it's a difficult. That's talking about complexity in general. People, you end up in the weeds pretty easily. So I appreciate you keeping us on a smooth path here, and but also letting us see sort of a bit of what lies beyond. And thanks for putting the presentation together. Thanks for talking us through this. And offline, I'm going to connect you with Eric, who's here, who I muted earlier because I think his mic was on, but I don't want to unmute him now and have him not be ready for it either. So anyway, thanks, David, and we'll follow up with you on the chat later. Okay. All
All right, awesome.
right. See ya.